Hello everyone, today we're going to work on getting started to start writing programs in assembly for DOS. So the first thing you're going to need is a couple programs on your computer. The first one you're going to need is DOSBox, and if you're on Debian or Linux Mint or Ubuntu, you can use the apt. Otherwise, there are other package managers for other things on Linux. So anyway, sudo apt install, we'll do DOSBox, and you can hit tab for auto completion, and also FASM, which is going to be the flat assembler. I already have them on mine, so I am good to go. There's also some extensions that you might like to have, and those extensions are, you're probably going to want FASM highlight. This program is helpful for highlighting your assembly code so that you can see what is valid and what is not. And then also this hex editor is another helpful thing for being able to actually see the binary. We probably won't dig into the binaries quite as much in this series, but it might happen. So always be ready, right? Also, makefile tools from Microsoft is another helpful thing because we will be using a makefile to automate some of this stuff for us. All right, so that's pretty straightforward. Let's get into our Hello World program. Let's start out by creating hello.asm, and we will be using 16-bit because it's DOS, it's a 16-bit operating system. And our origin point is going to be 100. Now you probably on other tutorials will see it this way. They're both the hexadecimal number for hexadecimal's version of 100, which is not 100 in decimal. It always gets confusing when you're trying to explain hexadecimal numbers this way. So it's 100, I guess. Anyway, if you want to learn more about hexadecimal, I do have a video called What is a Byte? It explains bits, bytes, nibbles, hexadecimal, binary, and all that other fun stuff. We will use 0x100 in this tutorial though. They mean exactly the same thing. Now, to actually show hello or hello world, depending on what I decide we're going to show at that point, we'll probably do hello world. Why not? Why break with convention? We will use function number 9 in the interrupt table. This is for interrupt 21. This is the ability to show strings. So if you're wondering what interrupts are and things like that, essentially what an interrupt is you are used to calling functions in other languages where you say something like print. And I guess more specifically, you would want to print hello world, right? Well, assembly is not quite this sophisticated with being able to call things by name. So what we do instead is the number 9 is the print function, basically. And what we have to do is we need to specify its parameter and then actually call it. And if we pull up interrupt 21 real quick, I can show you what number 9 is. So this is coming from bbc.nvg.org. It's the first hit on Google if you type int21h. If we look at number 9, you can see that it is the output a character string. You set AH to 09H, or you can do what I'm doing with 0x9, means the same thing. And then this is the data segment. By default, this will be set up for us. And DX points to the address that we want to use. It doesn't return anything. The string must be terminated with a $sign, which is character 24 in hexadecimal. And so let's look at what that actually is. I'll leave this up here as a comment to show what we're trying to accomplish. So what we're going to do is move into dx a string of some sort. So let's call our string hello, and we better define our string. So we're going to use a thing called a label. What a label is it's going to be left justified like this with a colon, and it marks a spot in memory. We're going to define a byte, or in this case, an array of bytes. We'll say hello world, and we need to end it with a $sign. Now we probably could have just put a $sign right here. That would mean the same thing, but I like to show it separate so that I remember that this is the end character, or the end of the string indicator. All right, and then after that, we're going to call int 21h. We also could do this as this way. Don't ask me why I do this convention, but for interrupts, for some reason, I always do the h on the end. I guess it signifies in my mind that it's not like it's an address or a number. It's kind of like a function call, but you can do it either way. There's nothing stopping you from doing it either way. So looking at it here, number 9, as we looked at, is output a character string. Then after that, we needed to set dx to where that string is. ds will automatically be set for us at this time. We don't really have to worry about that, and it must end with a $sign. So we said use the memory address here where hello world is currently located. And then int21 basically means look at AH and call that function, which is basically a print function. Now, you'll remember from C and C++, you always usually end with like a return 0 to hand back control to the operating system. And we need to do the same thing here. So to hand back control, we will pass in 4C00, and again, we will call interrupt 21h. Now you might be wondering, what does 4C00 mean? Well, let's find out where 4C is in our little list here. We find 4C. You can see it says terminate program with return code. So obviously we need to put in 4C in the high byte, and then the low byte is the error code. And 0 generally always means a successful operation. Now you can see you can also pass other return codes, like a 1 is a control break. Yeah, so if you ever wondered what that break key is on your keyboard, that is terminating a program ahead of time using the break functionality. You can pass a critical error, and there's other things. It also tells you to avoid using them. But you know what? If you're not writing for a company, you can kind of do the things that you want to do, and it'll be a learning experience, right? They're also telling you too what the conventions are, so that if you're using batch files, you can use that error level. All right, anyway, that explains that. Now, I should just explain, because if this is your first video, you're probably wondering what a high byte and a low byte is. AX actually is composed of 2 different bytes. There is AH, which we've used up here, and there's AL. So AH is the high byte, AL is the low byte, and a little neat trick with hexadecimal numbers, which is what we're using. Each hexadecimal character represents 4 bits. So if we were to look at this, this is the high byte, this is the low. Oh, don't want to click and drag. There we go. This is the low byte. All right, so let's run this thing and make sure what we did actually is working, right? So let's open up a new terminal here. And in our terminal, we'll run phasm, and we will specify hello.asm as our input. Now you can see it made a COM file. If you want to know the difference between a COM file and an auto executable, basically a COM file is not structured, and an auto executable or something that has the exe extension, auto executing, it has structure in it. Also, COM files supposedly cannot exceed 64 kilobytes, if I remember correctly. However, as DOS grew and things got bigger for compatibility going backwards, like when command.com got to be too large, that it technically was supposed to be command.exe, they basically got rid of those specifications so that the COM files didn't have to be renamed in every single batch file that anyone ever produced before that point. So this day and age, they don't really mean a whole lot from one another. COM and exe are pretty much the same thing, but you just got to walk down memory lane for whatever that's worth. All right, so without further ado, let's actually run this. If we run DOSBox, I guess a quick tutorial on this is if you type intro, it will explain things to new users, and it says if you want to actually have like a file system, you have to mount things. So what you can do is mount the C drive and then specify the file path that you want to use. And then after that, it will appear on your computer. And now I have to keep going through all the little things here, through the introduction. All right, we're back to where we want to be. Now, for me to be able to mount this, oh boy, this is going to be a long file path, I suspect. Let's see here. Where is this actually located? So my desktop under tutorials, DOS assembly getting started. That sounds about right. So let's run it by hand once. And don't worry, we will be automating this process because typing this in every single time would be not enjoyable. All right, so tutorials, DOS assembly. Oh yes, we also are going to need double quotes. Getting started. And cross your fingers. It worked. Good. Now we can go to the C drive, and if we list what's in here, you can see that we are currently showing our folder is the C drive. So now if we run hello.com, it says hello world. So congratulations, our first program worked. You have created a DOS assembly program, but don't run away quite yet because we still are going to make this easier, right? Typing in all that stuff, that was not that enjoyable. At least it wasn't for me. So let's add a makefile. And don't forget, lowercase f on file. Have made that mistake multiple times in the past. All right. So for all, what we'll do is we'll put in our FASM hello.asm, and we'll also make a run command. And our run command will call DOSBox, and it will run the command for us, mount C, and in my case, this is my file path, desktop tutorials DOS assembly. Yours will probably be an easier path than this, but that's all right. Now, remember we wanted to include quote marks as well, though, because there are spaces. So if you use the backslash character, that will basically mean keep my quote in this string. Don't leave the string, don't exit. Next, what we'll do is we're going to pass in another command that says switch us over to the C drive, and another command that says run hello.com for us. So let's take a look and see how this works now. Control-C is the break command on Linux. If you're wondering how I just killed DOSBox with the single click of a hotkey, or typing of a hotkey, pressing, mashing, whatever you want to say, that's how. Anyway, so now we can run make. And it assembled for us. And now if we do make run, it automatically will run our program for us. So there you go. So what we've covered today is we have looked at the basics of how to get started. We've covered extensions that are helpful, and we've actually written a Hello World program. And if you enjoy this content and you're still here, please do consider subscribing. It helps the channel and it helps get this information out to a larger audience so that all your friends and family can also learn how to do this. If you did like this video, the like indicator, you can click that. That helps indicate to me that you enjoyed it, and I know to keep making lots of this content. All right, I usually forget to say that. That's why I threw it in at this point, so I don't forget completely. Anyway, we have our program, which we stepped through pretty carefully of how it works. And then we also had made a makefile to make our lives easier so that we are able to rapidly develop. Now, to exit DOSBox, if you don't want to keep killing it by doing Control-C in the terminal, you can just type exit and it will exit the normal way properly. So I hope you enjoyed this video. We look forward to seeing you in the next video. We also have other content on our channel, such as BIOS programming, which will tie into this very closely, so you can check that out. And then there's other high-level options. There's even programming calculators. So be sure to check out all the different things we have going on this channel. Anyway, we look forward to seeing you in the next video.